In this lesson, we'll start our discussion on learning target number 2. By the end of the lesson, you should be able to determine the number of particles or moles in a chemical sample if given the other of those values. You will also be able to convert between the number of molecules and atoms in a sample. Different compounds consist of various types of particle building blocks. If you're working with an element, its particle type is known as an atom. A sample of a molecular compound contains molecules, which are made up of atoms bonded together. The particle type of an ionic compound is known as a formula unit. It contains ions that are bonded together. When doing calculations, it's really important to keep track of what unit and what chemical you're in. In some questions, you may be required to use a conversion factor in order to change one particle into another or one chemical into another. Here are some examples of how to do that. Example 1a. How many oxygen ions are there in 30 formula units of aluminum oxide? Because aluminum oxide is an ionic compound, the particle type is known as a formula unit. I can convert into how many oxygen ions are in that sample. We use the term ions because the oxygen is going to have a charge on it. I begin the question by writing the number down that I'm given. 30 formula units of aluminum oxide. And then I set up my conversion factor times want over have. I want oxygen ions, so that goes in the numerator, and I divide that by formula units of aluminum oxide. Then I ask myself how many oxygen ions are in an Al2O3. Using the formula, there's 3 oxygen ions for every 1. Remember, conversion factors work because our units that we don't want cancel out. I have formula units divided by formula units, and my answer will be in oxygen ions. Then I follow through with the math. 30 times 3 divided by 1 gives me 90 oxygen ions. Let's have a look at example B. If I have 15 molecules of PCl3, how many atoms are there in the sample? Remember, PCl3 is a molecular compound because I have just nonmetals. That's why the particle is known as a molecule. I start my question by writing down the number that's given to me. 15 molecules of PCl3. Now I know it takes some extra time to write down the word molecules in PCl3. Trust me, it's really important to keep track of what particle and what chemical you're in. I want to change this into atoms, which molecules are made up of. So I times by a conversion factor what I want on the top, what I have on the bottom. Then I ask myself, how many atoms are in a PCl3 molecule? Well, there's 1 phosphorus and 3 chlorines, so that's 4 atoms for every 1 PCl3. My PCl3s cancel out, and my answer will be left in atoms. Now I just have to do the math. 15 times 4 divided by 1 gives me 60 atoms. Remember, when you're doing these calculations, follow your SIGDIG rules. A special note though, in conversion factors, the 3 in the 1 and the 4 in the 1 here are absolute values. You don't count those as one SIGDIG. You can't have 3.5 oxygen atoms. So the final answer will be based on the 30 formula units and the 15 molecules that are in the original question. Chemical reactions depend on the number of particles present, not the masses that you mix together. Since particles are too small to count directly, scientists have to relate the number of particles in a sample to something that they can measure directly. One of the methods that we're going to discuss in the course uses the mass of the sample in grams and a unit called the mole. There are other methods that we'll talk about in other units. 1 mole is defined as 6.02 times 10 to the 23rd particles. This is known as Avogadro's number. Depending on the type of compound you're dealing with, the terminology changes. If you have 1 mole of carbon, which is an element, you'll have 6.02 times 10 to the 23 atoms of carbon in that sample. On the other hand, if you have 1 mole of carbon dioxide, you will have 6.02 times 10 to the 23rd molecules, because remember, CO2 is a molecular compound and its particle name is a molecule. If you're dealing with an ionic compound, such as NaCl, 1 mole will have 6.02 times 10 to the 23 formula units contained in it. Let's look now at how to convert the number of particles into moles and vice versa. The math equation relating moles and particles is big N equals little n times Na. This can be a little confusing because of the amount of n's there are in this equation. The big N stands for particles. The little n is the mathematical term for moles. And Na stands for Avogadro's number, which you just learned is 6.02 times 10 to the 23. Now Na is a constant, so you'll need to memorize that value. Let's do some examples. How many atoms does a 2.6 mole sample of silver have? This is a calculation that we can just use this math equation straight and don't need to rearrange. So if I plug in what I know, I'm looking for particles in this question because it's asking me how many atoms are there in the sample. So I'm trying to solve for big N. It tells me in the question that I've got 2.6 moles of silver. If I times that by Avogadro's number, that will give me the number of atoms in the sample. When I plug this into my calculator, it gives me a lot of digits in my answer. I'll just write down the first 5. It gives me the answer of 1.5652 times 10 to the 24. Now looking at that number, I need to round it following my sig-dig rules. The number in the question, 2.6, only has 2 sig-digs, whereas the value for Avogadro's number I used has 3. That means I can only include 2 sig-digs in my answer, so I have to round this to 1.6 times 10 to the 24 atoms. Here's my final answer. Example 2 requires us to rearrange the math equation. It asks how many moles are there if an NaCl sample contains 3.21 times 10 to the 23 formula units. Remember, formula units is a type of particle, so the 3.21 times 10 to the 23 gets subbed in as big N. Let's see what else I need to know. It asked me for moles, so that means in this question I'm going to be solving for little n. And I always know Na because it's a constant. So now I have to rearrange this equation so that little n is by itself. In order to get rid of this times Avogadro's number, I'm going to divide both sides by Avogadro. So if I take 3.21 times 10 to the 23 and divide it by Avogadro's number, I'll solve for how many moles are in the sample. Again, my calculator gives me lots of digits. I'll just write down the first 5. Now I need to round this using my sig-dig rules. Because I have 3 sig-digs in my particle number and 3 sig-digs in the number I use for Avogadro, I need to round this number to 3 sig-digs. Remember to include the units at the end of your answer. My units are going to be moles of NaCl. Example 3 involves the particle equation and also converting from one type of particle to another. It tells us that a sample contains 1.25 moles of NO2 and asks how many atoms are there in the sample. To start, we can figure out how many particles of NO2 there are. Now, because NO2 is a molecular compound, we're going to find molecules if we calculate big N. If I sub in my 1.25 moles and times it by Avogadro's number, my calculator tells me I'll have 7.525 times 10 to the 23 molecules of NO2. Now you notice that doesn't answer the question. The question asks me how many atoms are there. So because it's asking me about a different type of particle, I have to use a conversion factor. I'm going to times by what I want, atoms, and divide by what I already have, molecules of NO2. And then I ask myself how many atoms are in an NO2. Well, there's 1 nitrogen and 2 oxygens, so that's 3 atoms total for every 1 NO2. You notice the chemical NO2 cancels out, and my final unit will be left in atoms. My calculator tells me I'm going to have 2.2575 times 10 to the 24. Now I need to round my final answer using my sig-dig rules. The 1.25 in the original question has 3 sig-digs, and so does Avogadro's number. So I need to round this to 3 sig-digs. 2.26 times 10 to the 24 atoms. Now that you know how to convert particles in moles and moles into particles, we're going to start our Unit 3 assignment. You should have printed off a Unit 3 assignment checklist. Do the practice problems listed under the Particles to Moles section in your textbook. Answers are provided. Make sure that you check your answer to make sure it's correct, and that you include the correct number of sig-digs and units to get full marks. Put a box around your final answer or highlight it so it makes it easier to find when it gets marked. All of your assignment questions will be due at the end of the unit.